Hey everyone, welcome to the second lecture of our newly created placement series. So in this video, we'll be talking about entire searching algorithm, and you only require to learn two searching algorithm. One is linear search and one is binary search, which is very important. And in most of the cases, binary search would be useful, and in few of the cases, linear search will be useful. Linear search is very easy. Binary search is somewhat trickier, but if you understand, you can find the magic of binary search, and you will be totally amazed that using binary search, how quickly you can get the search result. So let's talk about both the searching algorithm in details. But before that, special thanks to Unacademy for sponsoring this video. So if you are an upcoming GATE 23 aspirant, then you can get up to 39% discount on GATE and ESE entire courses. So this offer is specially valid for Unacademy Iconic subscription, where you get the live classes from India's top educators. As you can see, the top educators in this GATE industry will be teaching you on this Unacademy platform. On top of that, you will get one-to-one mentorship, you will get one-to-one guidance. If you have any question, you can ask between the class, and after the class you can solve your doubt. You can also get access to physical notes which will be delivered to your home if you take the Iconic subscription, and along with that, the entire test series like subject wise, topic wise, and the full length test series along with some mock tests will be provided in this package. So basically in this offer, if you will be taking 9 months of subscription, you will be getting 2 months of subscription for absolutely free. If you take 12 months, 3 months will be free. If you take 18 or 25 months of subscription, 4 months of additional plan will be given to you for free of cost. But this is a limited period offer. Hurry up till the offer ends. So what you have to do, just use my code Manish M10 to get this offer unlocked, and you get up to 39% discount on the entire GATE and ESE subscription. So hurry up before the offer ends, and with Unacademy, let's crack it. So let's first talk about linear search. It is very easy. So let's say you have an array and you have set of elements inside an array. It could be integer, it could be a floating point number, or it could be a character, or whatever the thing present inside the array. So you need to find a particular element inside that array. So you have to return the index of the array, which means the position in which you can find that array. If you can't find that element in that array, you can return -1 or any other thing. So what you have to do, you have to traverse the array from left to right or right to left, or in both the directions. So there are actually several kind of linear search, but that won't improve the asymptotic complexity of linear search. It would be always linear in case of searching algorithm. So let's see how you can search the algorithm. So let's say you have this array 3, 5, 7, 2, 1, 4, 8, 9, 12, 15. These elements are present inside your array, and in the red color I have written the index of the array, which means what are the index of each and every element, and array index starts with 0. So we have total 10 elements. So index will start from 0, it will go up to 9, right? Now let's say I ask you to find the element 8. In linear search, you have actually no other option but to search the array from one corner to another corner. So in that case, if I search from the left side, it would go from the left side to until the right side, and in between, if you find the element, you can return the index. If you can't find it, return -1. So in the first case, you will search this element. It is not equal to 8, you will move on to this element. It is not 8, you will move on to this element, and up to this you will move on to this element, and you will find that 8 is actually present. So you will return this index. This array index 6 would be returned. So this is the overall linear search algorithm, but how can you write the code? So it is very simple to write. So let's say you have a function that takes an array as a parameter, and it takes the value that you are looking for, and it will return the index of the corresponding array position. So what you can do, as it will be returning some integer value, so that will be int, let's say linear search. This is your function name, and it is taking array as a parameter, right? So int array. Also it will take the value of that array, or maybe the size of the array and the value that you were looking for, right? So what you can do, you run a loop from the left hand side to the right hand side, right? So your loop will be start for int I equal to 0, I less than equal to, I less than n, and I plus plus. What you can do, if just put a if condition, if array of I equal to x, that the element you are looking for, you would return the index I, and else you have nothing to do. You can go back to this loop again, and while this loop will be exited, if you cannot find the value inside that array, you will return -1. So in main function, just write if you have received -1, so the element is not present inside array. If you have written something else apart from -1, the array element is present at that corresponding position. So now tell me, what would be the time complexity of a linear search? So what you are doing a search from left hand side of the array to the extreme right hand side. Let's say the element is present at the first position. So what you can do, you can immediately get the first element of the array and you will return the index. But if that element is present on the last index, what you have to do, you have to search the entire array. So you are basically searching the entire array. So whatever the size of the array will be, you will be searching that many number of steps. So if the array size will be n, the worst case time complexity would be order of n only. So this is the time complexity of a linear search algorithm. So let's see in the binary search how you can improve this time complexity. So binary search is a special type of searching algorithm and it follows the divide and conquer strategies. Let's first understand what is a divide and conquer method, and then you can understand binary search quite easily. So what is the divide and conquer strategy? That if we are given such a situation where we can divide the problem in more than one part, it may be 2, it may be 3, it may be 5, it may be 10, whatever, but more than one part we can divide our problem and we can focus only one part of the problem and we can ignore the rest of the parts. That is the main concept of divide and conquer. So let's say you have a problem, you have an array. So using divide and conquer, you can divide it into 2 parts, you can divide it into 4 parts or even 10 parts, doesn't matter. But you can only focus a particular part, this part or maybe this part or maybe some other parts, but you can focus only a particular part, and if that particular condition is satisfied, then you can find your solution in that particular part only. You can ignore rest of the parts. So that is the beauty of divide and conquer. It breaks the problem in some different parts and it allows you to enter a specific region where you can find your corresponding element. So that is what the same thing binary search will be doing. So let's see how binary search can improve the time complexity drastically. So as I said in the divide and conquer, if we are given such a situation, and that situation for binary search is the array or whatever the things that you are searching, whatever the data structure you are using, that data structure should be sorted. Whether it would be array, whether it would be linked list, doesn't matter. That particular data structure should be sorted. So if your array is already sorted, you can apply binary search. Otherwise, you cannot apply binary search. So that is the beauty of a divide and conquer strategy. So there should be a particular condition has to be met and we can apply the divide and conquer strategy. So in our binary search, that condition is our array should be sorted. So let's find an example and how we can apply our binary search. So now let's look at a following example of a binary search. Let's say we have a sorted array 3, 5, 6, 7, 9, 12, 13, 15, 18, right? So we have the array that is already sorted. Okay, first of all, let me tell you the element that you are looking for. It may be 15, right? So you are looking for the element 15 inside that array. So we'll be directly going to the middle element of that array. What will be the middle element? The middle element is this element, right? This 9 is your middle element. Now, if we go to a middle element, what information do you have to the left side as well as the right side of this array? What information do you have? Just pause the video and comment it down. What information do you have? Because the array is already sorted. So you have a particular information that if we go to a middle element, you find the middle element is 9. So that means as the array is already sorted from increasing order, so all the left side of that particular middle element will be less than 9 and all the right side elements of 9 will be greater than 9. Why? Because the array is already sorted. It is sorted from left to right. What is the element you require? You require to search 15. Is 15 greater than 9? Yes. So obviously we'll be looking on the right hand side because 15 is greater than 9. It should be present. If it is present, we don't know whether it is present or not, but if it has to be presented, it should be on the right hand side. It cannot be present on the left hand side because 9 is the middle element. So we'll go and we'll move our search to these positions only, right? From here to here. We'll not look on the left hand side. So this left hand side, all these elements we can exclude. This left hand part we can exclude from our searching domain. We will not look into this left hand side. So our problem is divided by 2. Right? We have divided the problem into 2 equal parts. We'll not care whatever the elements present in the left hand side will not check, right? So this is the beauty of a divide and conquer strategy. If a particular condition is met, we can divide the problem in several parts. In this case, as it is a binary search, we can divide our array in 2 equal parts. Now, what are the elements we have to search for? 9 is already done. 9 is not equal to our required element, that is 15. 9 is not equal to 15. So 9 is done. All the left hand side element is done. So what we have actually 12, 13, 15 and 18. So this is our new array we'll be looking at. What was the index? 5, 6, 7 and 8. So this is our new array. We don't care whatever the elements present on the left hand side and what is the middle element. We don't care. Now again we'll go and find the middle element. So as there are even number of elements present, we can choose middle element as to be this element. It could be this element or it could be this element. So in our case, let's choose this element 13 as our middle element. On the left hand side of the 13, the element that are present are lesser than 13, has to be lesser than 13, and on the right hand side there has to be greater than 13. What we require? We require 15. Is 15 greater than 13? Yes. So what is our search domain? We search on the right hand side of 13. So we'll again ignore this left hand part. We'll go and search this location. So our search domain has again reduced. We have only 2 elements, 15 and 18. Index is 7 and 8. Now what is the middle element? As there are even elements, so we can consider this as a middle element. You can also consider 18 to be your middle element, doesn't matter. So let's say 15 our middle element. Is 15 equal to our search element? Yes. Then we'll return the index 7 here, right? 7 will be returned and we'll say the 15 which is our required element is present at the 7th index inside our array. Now binary search is complete. So how many steps we are actually searching? In case of linear search, we have to search all the elements from left hand side to right hand side. But here, how many steps we are taking? First we look at this middle element. 1 step is required. Next we look at this middle element. 2 steps is required. Next we look at this element. Only 3 steps is required. Total there was 9 elements, but we have found out our required element in just 3 steps. That is the beauty of binary search. It drastically reduces the time complexity. So let's find out how to code it down, and uske baad we'll discuss the time complexity and how to calculate the time complexity of a binary search. So there are actually 2 types of binary search. One is iterative search, one is recursive search. What is recursion? We'll discuss later inside a video. So in this video, I'll tell you a very brief story about recursion, how recursion actually works. First, let's see the iterative binary search. So let's say binary search is our function, binary search. So what would be the parameter? Our parameter would be, well, I am writing the pseudocode. I'm not writing any C++ or Java code. I'm writing pseudocode. You can write that code in your particular language, whether you are comfortable in Python, Java, C++, doesn't matter. You can write in your own language. I'm writing just a pseudocode. So binary search, what would be the parameter? The parameter would be array, right? Next, what is required? We required our desired element, which is X in our case. Also, we require some left pointer as well as right pointer. So we can write left as well as right. So what are these 2 pointers? These 2 pointers indicates the left index of our array and the right index of our array. So why these 2 are needed? Because we are not searching the entire array. If it would have been entire array, our left index is always set as 0, right index will be always set at n-1. But here we are not taking care of the entire array. In each of the iteration, our search domain will reduce. So that's why we are taking care of the left as well as right pointer of our particular array. So what is our first step? First step is to calculate the middle element. How can you calculate the middle element? Mid equal to, well, there are 2 types of calculation of middle element. You can write left plus right divided by 2, but this method I don't prefer because you will be getting some wrong answer because of integer overflow. Let's say the array is having a huge size. Let's say 10 power 9, 10 power 10 elements are already presented inside an array. So in that case, that left and right pointer, if you add it together, it will overflow the maximum integer value that your computer can store. So if it would be int or if it would be float or whatever the thing, you will be having some integer overflow. So that's why I don't like this method. So instead what I can do, I just eliminate this mid step. I calculate mid in this way. Mid should be equal to left plus right minus left, this divided by 2. Now in the function itself there will be a loop. In each loop we'll be computing the mid element and we'll then decide whether we should go to left or we should go to right. So in that case we have to write the loop here. How much time we run the loop? We run the loop until the left pointer and the right pointer will not merge together. So while left is not equal to right, we'll run the loop. So now inside this loop we'll continue finding our mid element. And what is our required condition? If array of mid will be equal to our required element, that is x in this case, will return the mid index, will return mid. Now what does this statement means? As you have already seen, if the middle element is your required element, so always we look at our middle element. If it is equal to our required element, we return the middle index. So in that case we return 7 as the index, right? We return 7 back to our main function. So we'll always take care of our middle element. So we always look whether the middle element of that array is equal to our desired element. If it happens, we return the middle index. If it not happens, what you can do? Now let's say the middle element of that array is not equal to our required element. So what option do we have? As I already said, if that middle element is not equal to our required element, we'll check whether the required element is greater than our middle element. We'll search on the right hand side. If it is less than the middle element, we'll search on the left hand side. So we'll just write here, else if array of mid is less than x, that means the middle element is less than your required element, so we have to search the right hand side. Our right pointer will remain same and the left pointer will be modified to left equal to mid plus 1, because we have to search from this location to this location, right? So our left pointer would be mid plus 1, right? Else if our middle element is greater than the required element, else the left pointer would be same, because we have to go to the left hand side. The left pointer would be same and the right pointer would be equal to mid minus 1. So if it is in this region, our left pointer is same, our right pointer should be in that position, right? So this is the simple binary search algorithm, and we have to run this loop from until left not equal to right. If left equal to right, that means we are merging in a single element, and if that element is not our required element, we return -1 or some negative value to indicate that we have not found that particular element. So now let's look at the recursive method of a binary search. This is exactly similar to the iterative method, but in this method we'll eliminate the while loop that we already said, that left not equal to right. As you can see, we'll eliminate this entire while loop and we'll run this loop through our recursive search. So in any recursive function there would be a stopping condition, because every time we call the recursive function again and again, so there should be a stopping condition. So what is our stopping condition here? The stopping condition here would be if our left is greater than right, we'll stop, we'll return some -1 or anything, else we'll go on this particular segment. What operations we did? Exact same thing. We calculated mid, we checked the condition, else which also checks another condition, else we checked the remaining condition. The same thing we'll also do in the recursive search, but in some different ways. We first calculated the middle element, that is the same, left plus right minus left by 2. Now we check array mid equal to x. If the middle element is our required element, we return the middle index, else the middle element is less than our required element, which means we have to search on the right hand side. What we can do? We can again call this function binary search. So we have to return binary search. Now here look carefully, the parameter will be different. We'll send the same array as again we send the required element as it is, but the left and right index would be changed. In that case, when we have to search the right hand side, what would be the left index? It would be mid plus 1 and the right index would be right. So we'll call this function and again it will go back to this position with a new left and right value. It will again be executed, right? Else what we did, we have to search on the left hand side. So we'll return binary search. We'll pass the same array, we'll pass the same required element. In that case our left would be same, and in that case our right would be mid minus 1. So again it would return to the same function with the new left and right value. It will again be executed in that way. So this is our recursive function. If you find very difficult to understand the recursion, please do wait. There will be a recursion videos coming soon. So let's focus on the time complexity of binary search. So now understand carefully. Every time we find the middle element and our array, the entire array segment is divided into equal parts. So whether we have to go to right part or whether we have to go to the left part, our entire number of elements will be reduced by 2. If it is not equal to 2, it will be roughly 2. You can call it as a floor of 2. So if it is the middle element, the next search of element, the next domain of elements, जहाँ पे हम search करेंगे, the number of elements will be reduced by 2. There are total number of 9 elements, it would be reduced by 2. What would be the floor? It would be 4. How many elements left? 4. Right? 12, 13, 15, 18. How many number of elements we need to search on the subsequent stage? Again, we find the middle element. We find that this is our search domain. The remaining element is 2. 4 by 2 floor equal to 2. Right? So every time our number of elements that we need to search will be reduced by 2. So that often is written as T of n. If you have not watched my time complexity videos, please watch it here. I have explained in details that how you can find the time complexity of any program. I explained everything in details. So here Tn denotes the time complexity function of n elements. So every time, in every step, our element is reduced by n by 2 and we do some constant amount of operation in the array. What constant operation? Finding the middle element and checking whether the middle element is equal to our required element. So in the next time when we have n by 2 elements, it would be n by 4 plus c. For a constant term, we are denoting it as 1. So in the next part, it would be t of n by 4, it would be t of n by 8, 4 by 2, 8 plus 1, right? So it will go until this element will be less than 1. If it is less than 1, we'll stop because we have no other element to search for. Until it is 1 or greater than 1, we continue looking for our required elements. So just look at an important step here. In every step, n is divided by 2, right? So in that similar way, n by 4 we can write 2 square and n by 8 we can write 2 cube. So let's say it is going up to n by 2 power k should be less than equal to 1, right? So it would be 2 power k less than n or k should be less than log n. So this is our asymptotic bound. How many number of steps? This k number of steps, this entire recursive function will execute, and k is upper bounded by log n. The maximum number of time we can search inside that array is log n. So let's say we have 2 power 10 number of elements inside our array. We only require log of 2 power 10 elements base 2. This is equal to 10. So 2 power 10 number of elements we can only search within just 10 steps. That is the beauty of a logarithmic function, and that is the beauty of binary search. So I hope with this video you understood how linear search works, how binary search works, how to write the binary search code, and how to find the time complexity of binary search. Keep preparing some problems. I'll probably link it down in the description. Few of the problems related to binary search. This is very important topic. You can also go to Geeks for Geeks or LeetCode to practice some of the problems. If you require any help, just ping me on LinkedIn, or you can do also comment in this video's comment section. I'll try to reply all of that. And if you like this video, please hit the like button and also do subscribe to my channel, and also let me know in the comment section if you need any kind of improvement और इफ़ यू लाइक दिस वीडियो प्लीज़ लेट मी नो इन द कमेंट सेक्शन। सो बस आज की वीडियो इतनी, मिलते हैं अगले वीडियो में। टिल देन टेक केयर एंड गुड बाय।